Okay, so basically just with the equation of the sphere, it's x minus x1 squared plus y minus y1 squared plus z minus z1 squared equals r squared. But I just want to show you the reason why as well. So if you have a point, a vector, and it's in a plane, and you have, if you had a sphere and it's in a plane, and its center is x1, y1, z1, and you have any point that lies on that sphere, we'll call it x, y, z. So you have any point on that, so it's x, y, z. Then wherever that P goes, anywhere on that sphere, its distance to the center is equal to the radius r. So if you want the distance that P, which is x, y, z, is from the center, which is x1, y1, z1, then what you're looking at is the magnitude, or like the distance formula. So it's x minus x1, y minus y1, z minus z1. The modulus of that should equal r. So that means that if you square rooted x minus x1 squared plus y minus y1 squared, and this is derived much like the circle, z minus z1 squared, you get r. So then from there, you're able to square the other side, and that's where this formula up here comes into play. This one. Okay, so that's the actual equation. In saying that, the actual vector equation of a sphere would be z minus your center, let's say it's x1, y1, z1, has to equal r. So that's just telling you the distance that z is, which is x, y, z, from that point. Now I won't put z there actually, because we use z for complex numbers, that's why I've got that there. Probably we use r. So r is the point x, y, z. The distance it is from x1 is equal to the radius, and that's in vector notation. Okay. All right, so find the equation of a sphere with the center that. So you go x minus 2 squared plus y minus minus 1 squared plus z minus 3 squared equals 4 squared. So you just have to make the 4 squared 16. Find the center and radius of this sphere. I'm just going to give you one. Y squared minus 6y plus z squared plus 4z. Minus 2 equals 0. Okay. So what you've got to do is put it into groups, and you just complete the square on each of them, halve it, and then you add it to both sides. Get x squared minus 2x plus 1, because you halve the 1 and square it and add it. Y squared minus 6y plus 9, because half 3 is 6 is 3, square it's 9. Z squared plus 4 squared z plus 4. Then I'm going to move the minus 2 to the other side, so that equals 2. So that means the things that I have added, I've added a plus 4, I've added a plus 1, and I've added a 9. So I have to add those to the other side. So plus 1, plus 9, plus 4. So now I end up with x minus 1 squared, because that's a perfect square, y minus 3 squared, another perfect square, and z minus 2 plus 2 squared. 9 and 1 is 10, that'll be 16. So the center will be 1, 3 minus 2, and the radius is root 16, which is 4. Okay, so this one here, that point will lie on the sphere. So when anything lies on it, if that point lies on it, that means when you sub it in, the x, y, and z value, then it will be true. So in place of the x, we're going to put 5. In place of the y, we're going to put 7. And in place of the z, we're going to put 2. And that will go for any equation. If something lies on it, or you want to show that it lies on it, you've got to sub it in for the x, y, and z value. And yeah, if both sides are equal, it's true. If they give you what lies on it, then you know that both sides are equal. So we know this is in fact true. Okay, so 5 minus 1 is 4. 7 plus 3 is 10. 2 minus 3 is minus 1 equals r squared. I think we get 116 plus 1 is r squared. R squared is 117. So therefore r is root 117. Okay.